Okay, let's go over Newton's second law. Okay, so the second law basically tells us that the acceleration of an object, so the acceleration, we will abbreviate that, depends on two main things. It depends on the mass of that object, and it depends on the force being applied to that object. Okay, so let's look at two scenarios. Let's first look at the relationship between force and acceleration. So let's say I have a person here and they're putting the force on a box. Let's say they put a force of 10 newtons on this 10 kilogram box. Okay, and we have another individual, same person, they're putting a larger force now, 100 newtons on the same 10 kilograms. Okay, so we know, we've seen in our simulations, and we've kind of seen this in real life, that when you put a larger force on something, it's going to have a greater acceleration, right? So when something has a small force, you're going to have a small acceleration. But when we have a large force, we have a large acceleration. Okay, so when one goes up, the other goes up. When one goes down, the other goes down. This is what we call a direct relationship. Okay, it's directly related. Okay, so in other words, if I make my force 2 times bigger, then my acceleration would be 2 times bigger. If I make my force 3 times bigger, then my acceleration will be 3 times bigger, and so forth. Okay, they're directly related. Okay, let's do 3 here. All right. What about the opposite scenario in which I have, let's say I have an individual here. He is, let's say I keep my force the same. I put a force of 100 newtons on a box that has a mass of 20 kilograms. Other person, same person, sorry, but they put 1,000 newtons on a, or actually, sorry, in this case, we're keeping the force the same. The only thing that's changing is a box. But now my box has a mass of 2,000 kilograms. Okay, same force, but one box has more mass. So what happens here? Well, we know that when there's a small mass, it's easier to push, right? We have a bigger acceleration. This guy's going to have an easier time pushing that. But when my mass goes up, when I increase my mass, it doesn't move that quickly anymore. My acceleration goes down. Okay, so when one goes up, the other one goes down. That's what we call a inverse relationship. When one goes up, the other goes down. Okay, and they go up and down proportionally, which means that if I make my mass 2 times bigger, my acceleration will be 1/2 of what it originally was. If I make my mass 3 times bigger, then my acceleration will be 1/3 of what it was. And if it's 4 times bigger, 1/4, and so forth and so forth. In other words, as my mass keeps going up, this keeps getting smaller and smaller and smaller, right? Because 1/2 is smaller than 1/3. All right, so let's look at the equation here, break it down, and then work through some practice problems. So our equation is, for the second law, is the force on an object is equal to the mass times the acceleration. Okay. You might also see, actually, let's just break that first. So F stands for force, M stands for mass, and A stands for acceleration. Okay. The units for force, which we've already been using, are newtons. The units for mass are going to be kilograms, and the units for acceleration, we should know this, are meters per second squared. Okay. All right. Now, really, all you have to do is be able to rearrange these equations for these type of problems. So let's take my original equation here, right? Force equals mass times acceleration. Let's say I want to solve for acceleration. I don't want to solve for force. So that means I have to get acceleration by itself. How do I do that? Well, I basically just move the m over. So right now I'm multiplying times m, so I have to do the opposite. So I divide by m, divided by m. Two things that are the same, cancel. Acceleration equals force divided by mass. All right, pretty easy. What if I wanted to find mass? Well, let's start with our original equation again. Now I need to move acceleration to the other side. So I move acceleration side. How do I do that? I just divide by A, divided by A, cancel. Mass equals force divided by acceleration. Okay, you could use a kind of triangle to organize your dots here as well. They would look like this, right? Because force equals acceleration times mass. If you block this, acceleration equals force divided by mass, and then mass equals force divided by acceleration. You can use this if it helps. Same thing as the other problems, but you don't have to, okay? Sometimes it's easier not to do that. It just depends. Okay, let's work through some practice examples and we'll go from there. So, you want to list everything when we're doing these problems, kind of the same thing we've done before. So, we have a skier that has a mass of 80 kilograms and accelerates at 2 meters per second. What force does that act on him? Well, I know my mass is 80 kilograms, and I know my acceleration is 2 meters per second squared. Okay? I plug those into our original equation, which is F equals M times A. Right? So that gives me 80 kilogram times 2 meters per second squared. So if we multiply numbers, 2 times 80 gives us 160. What are our units? Well, kilogram times ms squared gives us our units for force. We don't have to know why it is, but our units for force are going to be newtons. Those are our units for force. Okay, and that's it. You just kind of plug and solve. So let's look at another one here. In this example here, I am looking for mass. What is the mass of an object if it takes 40 newtons to accelerate it to a rate of 4? So it takes 40 newtons to accelerate a mass to a rate of 4 meters per second. So let's not put the units, let's just put the numbers. Okay, so there's a couple ways. Let's just do it by plugging everything in. So I'm going to plug it into this equation. So rather than F, I'm going to put 40 equals, I don't know, M times 4. All right, so if I want to get this to the other side, I have to do the opposite of times 4. So it's divided by 4, divided by 4. This cancels, and that gives me my answer. Mass equals 40 divided by 4. 40 divided by 4, that's just 10. What are my units? Well, I was looking for mass. My units for mass are kilograms. Kilograms. Okay. All right, let's keep moving on here. So, a net force of 15 newtons is applied to a cart with a mass of 2.1 kilograms. What is the acceleration? If you're not sure what you're doing, you just list things. Okay, we just list things and we go from there. Well, my force is 15 newtons. My mass is 2.1 kilograms. I don't know my acceleration. Let's say I wanted to use that triangle for this, right? You can do whatever method, just plug and solve, or you can use the triangle. Let's say I want to use this, so I block it. Acceleration equals force divided by mass. Acceleration equals force divided by mass. Okay, I plug in 15 divided by 2.1 equals, so this is not something that I'm going to do in my head. I can use a calculator for this one. So I grab my calculator and I'm just going to put 15 divided by 2.1, 7.14. I'll just round to that first decimal there, 7.1. What are my units? It is acceleration, meters per second squared. Okay. All right, one last problem. And I'm going quickly through these problems because they're very similar to our speed problems. We plug, we solve, and we're done. Okay. An object has an acceleration of 10, a mass of 2. What is the force? Well, we know force equals mass times acceleration. We're getting better, so we can start skipping this. Mass is 2, acceleration is 10. That gives me 20. What are my units? It's force. My units are newtons. Okay. Last problem here, you're looking for acceleration. I want you guys to just try this problem out. Okay. We'll leave that up there.